we are still working with the half angles here. Use the half angle identities to find the exact value of the following. Confirm your answer with a calculator, which I don't really spend the time on, but I do want to show you how it works. Again, Edmentum sticks more with the half angles with degree measures rather than radian measures, but I do want to show you example 2 so you can see something with a radian in it. A little bit of kind of a way that I work these out, and I do basically follow the steps. What formula are we going to use? It says sine, so we're going to do sine of theta over 2 equals plus or minus, and then it's going to be 1 minus cosine theta. Looking at the 105. Well, where is 105 on the unit circle? It's in quadrant 2, and in quadrant 2, sine is positive. So our answer is going to be positive. In terms of plus or minus, we're going to end up with positive. Third step, what we're going to do is we've got 105 here. We need to double that angle. So 105 times 2, that's going to go back into our formula here, because now we're going to finish by working with the formula. So this is going to be 1 minus cosine of 210 divided by 2. And cosine of 210 is 7 pi over 6. Again, I find it more helpful to work in radians. I have trouble with degrees, but whichever way works for you, the cosine of 210 be negative square root of 3 over 2. And then I can't forget, well, a couple things. Double negative here is a positive, so this is really 1 plus square root of 3 over 2 divided by 2. And now what we need to do is we need to simplify this expression. So, just as an aside here, and it's going to go into my cosine of 17 pi over 12, which I'm not going to do that problem. The square root of 3 over 2. Remember, when we're adding fractions, we need to find a common denominator. I don't think that your calculator will help, but 1 over 1 is the same thing as 2 over 2. Most people are pretty good with that part of the fractions. Plus the square root of 3 over 2. Simplify this. This becomes 2 root of 3 over 2. So now what we have in our formula here is we have 2 plus the square root of 3 over 2, and then it's all divided by 2, because I just did the 1 plus the square root of 3 over 2. That's what this part is. And then we still have the divide by 2, so there's our divide by 2. So now we need to simplify it, and I'm going to go old school. For square root of 3 divided by 2, I flip. This is going to become our formula here over to simplify this. So this, there's the top of the fraction. See it? There we go. There's the top of the fraction. And then we also have the square root of 4. So we're going to end up with 2 plus the square root of 3, we get 4, which is 2. And we are allowed to have a radical within a radical in these types of problems. So this is our answer to sine of 105 degrees. Now you might want to stop the video here. It's been almost 6 minutes on it. But I am going to do tangent of 3 pi over 8 because I would like you to see an example of a radian problem. So I'm going to go back up here. And the steps are still the same. First things first. Formula is going to be plus or minus, and it's 1 minus cosine of theta divided by 1 plus cosine of theta. And, well, 3 pi over 8 is in quadrant 1. So once again, because it's in quadrant 1, our answer is going to be positive. If it happened to end up to be in quadrant 2, tangent's negative in quadrant 2. So we would say the answer would be negative at that point. Step is that we need to double the angle. So when we double this angle, 3 pi, we multiply the tops of the fractions together, we get 6 pi over 8. We multiply the bottoms of the fraction. This, trying to put theta in terms of another angle that we already know. And if we simplify 6 pi over 8, we get 3 pi over 4. And we know the value of 3 pi over 4 in the unit circle. So this becomes 2 pi over 4 divided by 2. And again, we want to use this value problem. We know that our answer is going to be positive. And then we fill it in. So it's going to be 1 minus cosine of 3 pi over 4 divided by 1 plus cosine of 3 pi. So we'll fill in what those values are. And cosine over 4 is actually negative square root of 2 over 2. And we can do the double negative here once again. So this positive, actually just to write it a little bit better, this would be 1 plus the square root of 2 over 2. Square root of 2 over 2. And that is still all underneath our square root. And just like the previous problem, we need to be able to combine these. The nice part is that there's 1 in these formulas. So when we rewrite this, it's the same thing as 2 over 2 plus the square root of 2 over 2. And down here in the bottom, minus the square root of 2 over 2. So I'm going to go old school here for a minute. So 2 plus the square root of 2 divided by 2. Remember, we keep the denominator as is. And we're going to divide it by 2 minus the square root of 2 over 2. And what happens is that these 2's cancel out. And now what we're left with so far is we're left with 2 plus the square root of 2. Down here we're left with, be able to see it. And there's still some issue here. Because just like this last one, it was simpler because we just had the 4 that ended up in the denominator. We still have a square root within the denominator. So what we need to do is we need to get rid of that square root down there, and we're going to do that by multiplying by the conjugate. In the conjugate, remember you change one sign. So 2 minus the square root of 2, we change the sign to a plus, but we're going to use the fancy form of 1, which is going to require us to FOIL or double distributive both the top and the bottom of the fraction. Hopefully I don't run out of paper here. But we get 4 square root of 2 plus 2 square root of 2 plus square root of 4. Again, FOIL. Same idea here in the denominator. And I know I don't have the radical written, I haven't forgotten. 2 times 2 is 4, plus 2 square root of 2, minus 2 square root of 2, minus the square root of 4. But what we're trying to get to happen here, and it's truly, we need that whole radical there. We want to get these radicals out of the denominator. So as we look up here in the top of the fraction, we've got 4 plus 4 radical 2. This and this are like terms. Take the square root of 4. You might have even written it as 2 already. In the denominator, we've got positive 2 square root of 2 and negative square root of 2 out. That's what the conjugate does for us. And then we have 4 minus the square root of 4, which is 2. So we're now the finishing. If we combine like terms, 4 plus 2 is 6, plus 4 square root of 2. Down here in the denominator, 4 minus 2 is 2. And I don't want to forget that it's all underneath the radical. But finally here, what happens, really close, is that 6 and 4 and 2 are all even numbers, which means that they're all divisible by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. And then we can take the square root. And this is our answer.